When we're discussing series circuits and we make the point that voltage drops at the load, a lot of times students will say, but how come we don't just measure the resistance of the source side wiring and components, measure the resistance of the load and measure the resistance of the ground side? The reason for that is when you take a load, the load actually may have a very small amount of resistance, just like the wiring, and it becomes hard to differentiate which has the most resistance because the readings are all so close. In a short little circuit like this, there will be a little bit of a difference, but in an automobile, those differences become even slighter. So let's take a look at that real quick. I've got the circuit turned on, and I've got it disconnected from our source because we can't have any other voltage in the circuit when we're making measurements. So let's go from the wiring that would normally be attached to the source, and let's measure the resistance of the source side of the circuit. That's 0.5. Let's measure the resistance of the ground side of the circuit. That's 0.3, 0.2. And let's measure the resistance of the load itself. Now we saw a minute ago that the voltage drop at the load was almost all of our voltage, and very little voltage drop on the source and very little voltage drop on the ground. But in this case, our resistance across the load is around 0.7, 0.8. So the resistances of each part of the circuit are fairly close until there's current flowing. Once current flow starts to work in the circuit and the bulb heats up, its resistance actually increases and we get our voltage dropping at the load. 12.79, 0.02, and 0.18. So as you can see, voltage drop is a much better method for finding resistance, and it shows me where the true resistance of the circuit is.